thought I'd like to start by showing you a little bit of Oxford, if that's all right. Let's see if I can get this to work. So that goes there, that goes there, and you should now be looking at Oxford. You see, we're going to imagine that you've arrived at the train station and you're just walking up to the Open Day in the Maths Institute. I'm going to show you how to find the Maths Institute. So here we are at Oxford Station. There's lots of bikes parked outside. Lots of our students cycle around town. I think it's just slightly faster to cycle around town than walking. It means you can get up 5 minutes later. So here's lots of bikes at the station. This is the Side Business School, but we're not going to the Side Business School. We're going to the Maths Institute. Lovely sunny day. It says copyright 2019 Google in the sky. So the sky is copyright Google, good to know. And we're going to go this way, and instantly it's raining. So if you're not from the UK, this is pretty typical weather for the UK. Just changes like that from sun to rain, back to rain again. And we're going to go through here, up the road to the Maths Institute. Okay, so we're going into town. As we go in, let's stop behind a lorry. We're going to cross over the river, see the lovely spires of Oxford in the distance, and in we go to Oxford. On our way in, we're going to go past a couple of the colleges, and I'll try and point at colleges on the way through. You see, there's 29 different colleges that have mathematicians. Here's one of them. Here's Worcester College. So the colleges are where students live, at least in first year, usually maybe in second year or third year as well, and that's where students maybe have a canteen and some student societies, things like that. Right, okay. Big part of the character of Oxford is in the colleges of Oxford. Okay, we're going to go down here. And if we turned right at the end of this road, we'd be going into town, and we'd go into the historic centre of Oxford. But we're going to go left. We're going to go up St Giles Road. This is St Giles Road. It's the biggest road, past the Ashmolean Museum over here, down St Giles Road. So the Maths Institute used to be on the right down the end of this road past the War Memorial, but now we've moved to a shiny new building, which is why I want to show you it, which opened about 6 years ago now, which is just down here on the left. Just zoomed past Somerville College, which is perhaps the closest college to the Maths Institute. None of the colleges are very far from the Maths Institute in the grand scheme of things. Oxford is quite a small town, but if you're looking for the shortest walk from the front of your college to the Maths Institute, then that's Somerville, I suppose. And here we go, up to the Maths Institute now. Here we are on the left. I've just gone slightly too far past it. So here's the Maths Institute. This is the home of maths in Oxford. These photos were taken last year for our open day, when all the banners were up. This is where the lectures happen. This is where a lot of researchers have their offices. And it's where we would normally do the open day. And I can't show you the inside of the Maths Institute because the Google Streetcar didn't go inside the Maths Institute, but we did bring a drone inside and we filmed drone footage flying around inside the Maths building. So if you want to see that, then you need to go back to the Open Days page and click on See the Maths Institute, and you can watch this drone video of us flying a drone around inside the Maths Institute. Okay, fantastic. So now we're in the Maths Institute. We normally start with a bit of maths. And this would usually be with David Acheson. Here's a picture of David, sort of rock star of popular mathematics. Here he is in Oxford with his red guitar. He's famous for books like 1089 and all that, Journey Through into Mathematics, and also The Calculus Story. Those are two of his books. And we always start with a bit of maths. We wanted David to record something, but I'm going to do this live on stream. Okay, so here's a bit of maths from one of David's books that I really like. The maths works like this. It's an applied maths problem. You're trying to solve a problem in the real world. The real world problem looks like this. You've got 4 cities, and they're equally spaced, I suppose, at the corners of a square. Their names are A, B, C, or D. Totally realistic maths problem. And the thing you want to do is you want to build roads to connect all of these towns. And you want to save money. You want to do the shortest possible total amount of road. So here's an example of how you might do that. You might join up A and B those two cities, with a nice straight road. I should have said, maybe this square is sort of 1 kilometre along the side. Okay, so that's 1 kilometre of road. And then 1 kilometre of road down to here, and then 1 kilometre of road over here. And then here's the thing, you don't need to join up A and D because they're already connected. I mean, that's not very convenient for the people who live in A and D, but you don't need to build a road there. They're already connected via B and C. Okay, so in your minimisation problem, the total amount of road you've used is 3 kilometres of road. I'm going to write 3. So that's nice, but that's not the best solution that you could have, because after thinking a little bit more about more efficient road networks you could build, there's a more efficient one that looks like this, where you join up A and C, and you join up B and D with straight roads. My drawing there is not fantastic. So a little bit thinking, this turns out to be the length of these roads is 2 root 2, which is about 2.8, which is less than 3. So there's less total road involved in this network of road going between A, B, C and D, and all the towns can still get from each other to each other. So that's pretty good. But that's not the best solution either. There's a slightly better solution that I really love, that's not obvious at all. It works like this. So you take your 4 towns and you join each of the towns up to a junction in between. So these 2 are going to join to a junction over here. These 2 are going to join to a junction over here. And we'll build 1 road between the 2 junctions. And we'll make the junctions nice and small, so that these roads meet at a point. And if you make all of these angles 120 degrees, all of them, so this is 120 degrees, this is 120 degrees, this and this and this, then the length of road, and I'm going to leave this as an exercise to you, turns out to be, I think, 1 plus root 3, which is very slightly less than 2 root 2. So this is a slightly better road network. It uses less total distance of road. And it's not obvious at all where the solutions come from. So when I was reading David's book, I was really pleased to see this. He talks about the solution using bubbles and using surface tension. You see, this is an applied maths problem, and there are other things in the real world that want to minimise their total length. So he's got this lovely analogy where you think about soap films, or you think about bubbles, and the way that soap films behave gives you a reasoning for why this is a reasonable road structure, or why this might be what you expect for the best road network. I think that's really nice. There's a sort of link between bubbles and fluid dynamics, which is something that we learn about quite later on in maths, with this sort of geometry problem of minimising total length of roads. Okay, so that's a little bit of maths for you. Okay, always nice to start with some maths, isn't it? Right, okay. I asked David if he would say anything else at the end of his bit of maths at the start of the open day, and rather cheekily he mentioned that he's got a new book coming out. His new book is called The Wonder Book of Geometry. It's out in October 2020, and he asked me to mention it. Available at all good maths bookshops, I'm sure. David's a lovely chap. Right, okay. So this is going to be a admissions talk. My name's James. I'm the admissions and outreach coordinator. I think I said that already. So I look after the admissions process. And I'm going to run through the steps in the admissions process and a few tips about how to prepare for applying for maths at university or for maths at Oxford. My first 2 slides are explaining why you might want to do that. Maybe I don't need to say, maybe it's already obvious to you why anyone would want to study maths at university. But here's a slide on why maths. Maybe you enjoy working things out. Maybe you enjoy solving problems. Maybe you want to do things where you build on maths you've already seen to build new theory. Maybe you like the way things are logical and things follow from simple axioms. Maybe you like the way that simple questions can have complex answers and complex questions can have simple answers. For problem solving, maybe you like coming up against a challenge or a puzzle that you don't know what to do with straight away, and you enjoy coming up with using all of the skills and tools that you've got to build a solution to that problem. And that could be anything from a maths puzzle to a real world problem to something in your actual life that you really want to solve. So my last bullet point is you might study maths because you want to make a difference. I genuinely believe that studying maths is a good way to prepare you for making decisions later in life, and it's good preparation for employment later on. Okay, so maybe I don't need to sell maths to you. You've clicked on a maths open day. Presumably you're at least slightly interested in maths. I think maths is really great. I think it gives you a lot of skills to solve whatever sort of problems you want to solve, as well as a lot of specific theory. If you're really interested in maths, if you just really like maths, that's a great reason too. We've got a lot of maths in our maths course, so if you like maths, you'll probably like what we're doing here. Okay, quick sell on why Oxford as well. Here's my advertising slide for Oxford. First thing, and I think this is most important, we've got quite a challenging course. We've got a lot of maths there. We set a lot of work for our students to try. We try and set enough questions on the problem sheets that they've always got something to think about, that no one's ever finished everything and puts their feet up. There's always some more maths they could be thinking about. And we're looking for people who rise to that challenge and want to spend lots of 3 years or 4 years doing maths problems. So we've got a lot of maths content going on there. We've got a collegiate atmosphere, which I really like. It's this set of different colleges. It means that although we're not a very big university or in a very big town, within that there's smaller communities. The colleges have student societies and kind of student body and tend to be quite friendly and have this collegiate atmosphere that's quite nice. People tend to... So maybe there's six or seven mathematicians at your college who you know really well because you see them lots more than other people around town. We've got tutorials, which is our selling point of small group teaching. So there'll be 2 or 3 students, 1 tutor who might be a lecturer or a professor or a graduate student or me, going through some maths from the problem sheets. So extra support means that we put lots of content in our lectures. We know that our students are going to put some of their own time into trying the problems. And then we've got the tutorials to catch up with anything they found really tricky, or to help them with things from the course. Or to talk about where the course is going next, or other interesting bits of maths that are similar. So we've got this small group teaching that might be a bit unlike anything you've had before at school or college. You might be impressed by the academic reputation of our course and tutors, and you might like the employability numbers of our graduates. We have these big careers fairs in the Maths Institute where lots of employers come along and are quite keen to hire our mathematicians to go and do different jobs around. Okay, right, so I've convinced you why maths and why Oxford. Let's do a little bit of admin. Here's the process, just to make it clear for everyone. I imagine you've heard things like this from your schools and teachers and everyone before. Here we go. So you apply to university in the UK through something called UCAS. UCAS will ask you to write a personal statement and to list things like your previous qualifications and exams that you're going to take. We also ask you to register for something called the Maths Admissions Test, MAT. More on the maths later. The next step, though, that you do is you take the MAT. So this is a maths test we ask everyone to do, and we get your MAT scores in before we've made any decisions, before we've decided, before we've rejected anyone. We get your MAT scores. So we look at your application as a whole with your MAT score as well. We shortlist about 30% of our applicants for interview. We're lucky we get loads of applicants and we don't have the resources to interview everyone. So we shortlist down to about 30%. Then we run interviews, so we interview those people, we ask them maths problems, we see what happens when we do maths live with them, and we make offers to about a third of the people we interviewed. So we've shortlisted down to about 3 per place, and then we make offers to about a third of those. Final step is you make the conditions of your offer. So usually our offers are conditional to say you've got some upcoming A-levels or equivalent or more exams that you listed on UCAS that you haven't taken yet. We ask you to get particular grades in those. And then if you get those grades, you've made the offer and you start the course. I'm going to say that people tend to focus in on the A-levels part of this, or the meeting the conditional offer. And I know that A-levels are super important to you right now if you're in a school in the UK, they're what you study for 2 years. But they're not the sort of final hurdle, really, or they're not really a selection barrier. We're not in the habit of making way more offers than we have places. Almost all of the people we make offers to go on to make the conditions of their offer, e.g. A-levels. So the thing that they get the grades that we ask them to, maybe motivated by having an Oxford offer. So we don't really lose people during this step. We're much more interested in things like the MAT and interviews, where we get to do some maths questions with you, and that's how we shortlist down the numbers and how we choose to make offers to people to go down from about 9 or 10 applicants per place these days, down to the number of offers we make. So it's sort of necessary that you'll be doing well in school and that you've got good predicted grades, but that's not the thing that we use to really sort between people so much. Okay, enough on that. More facts about the maths submissions test. So it's going to be on the 4th of November 2020 this year. It's 2.5 hours long, which might be a little bit longer than you're used to for a maths test. And it's got a mix of multiple choice questions and longer questions, where you'll need to show you're working out and maybe prove something or give reasoning for something along the way. It's designed to be approachable by everyone, including people who don't have further maths in the A-level system. So in terms of A-level, it's based on just the first year of single mathematics, with a couple of extra topics that we think you learn in the start of next year on single maths. There's a very limited syllabus of topics that we expect you to know. That's available on the MAT website. So there's a syllabus there, loads of past paper questions, solutions, and lots more over at maths.ox.ac.uk/r/MAT. A link to that page is also on the Open Days website. If you're on the Open Days website, you can click on Matt's information to get a link through to there. There's a video up of some preparation practice problems and other resources like that. Okay, there's a lot of admin talking, so I want to show you a math question. I want to do some maths again. So here's a past math question. This is one from 2018, and it's very close to my heart because I wrote this question. So this is a 2018 multiple choice question, and the point I want to make, we probably don't have time to do this question right now, but the point I want to make is that the question is about e to the kx, and it's about derivatives. There's this one fact on the syllabus that by the 4th of November 2020, we expect you to have seen the derivative of e to the kx. So we expect you to know if y is e to the kx, then what is dy by dx? But that's not the whole question. That we don't just ask you, can you recall that fact? We ask you to use that fact in an unfamiliar context. And where here I've got, I guess this is some horrible differential equation. And I'm really not expecting you to solve this horrible differential equation. That would be math. It's really hard. I have no idea how to solve this differential equation. But I do expect you to be able to know what the derivative of e to the kx is, and to work out what the second derivative of e to the kx is using that fact. And then once you've plugged it in, I expect you to be able to have some sort of fluency to solve some sort of algebra once you've plugged that thing in, so that you can rearrange it and try and turn this into an algebra problem. Probably don't have time to do this question live, which is a shame. Maybe we'll come back to it later. Yes, okay, so this is a short question, multiple choice question that we used in 2018. Okay, and it's that combination of, do you recall this thing, do you know this one fact from the syllabus, but then also can you use it in an unfamiliar setting, and do you have the sort of fluency to solve the algebra problem that falls out at the end? Okay, so that's a math question. It's a maths test. We want to see if you can solve maths problems. Okay. Yes, more admin details, I'm afraid. If you're doing A-levels, then I hope we've got this far. Maths is required. We expect you to be doing maths. If your school or college offers further maths, then we expect you to take that opportunity too. It's highly recommended. I'm a big fan of further maths. I think it's a really good course. It's how you learn about complex numbers. But we know that some schools and colleges can't teach further maths A-level. In that case, we consider you based on the maths that you're being taught. We don't want you to be disadvantaged because your school or college couldn't teach you further maths. You should let us know about that in your application somewhere, either in your personal statement or in your teacher's reference. I know that you don't write the teacher's reference, but you should try and encourage your school or college to note that you couldn't be taught further maths, just because you're missing out on complex numbers. The deadline is 6 p.m. British time on 15th of October. You also need to be registered to take this maths submissions test. Most people are going to take this at their schools or colleges, or you can take it at a registered test centre. If you're taking it at your school or college, they need to register as a test centre. Or if you're taking it somewhere else, then they need to register you. So you need to get in touch with the exam centre where you plan to take this test. They need to sort all of that out by the 15th of October, including registering as a test centre if they're not already. It's best to make sure that your school or college knows that you're going to do a test on the 4th of November. I've been told that registering for this test is no more complicated than registering for other exams. So if you sit normal exams at your school or college, then you should be able to sit this one at your school or college too, I hope. There's a website there, admissionstesting.org, for details of the sort of boring admin details of how that registration process works, and a list of other registered test centres if you can't sit it in your school or college and you want to find somewhere else to take this test. Okay, 4th of November, right, good. Okay, so that's the MAT. And I think next I want to address this other point about applications that we get quite a lot of questions about, which is the colleges again. So I've said a couple of times there are 29 different colleges that have mathematicians. And at this point, some people would be wondering, I wonder which one's best, or I wonder which college I should apply to help my chances of getting an offer. And here on this slide, I'm going to say that the colleges are much more similar than they are different. They all have the same lecture content because all of the lectures are everyone together in the department. They all have the same problem sheets and the same exams at the end of the course. They're all worth the same degree. They teach the same maths. And they're all about the same size in terms of mathematicians. They've got different buildings and different places in town. You might look at some pictures of a college and decide that it's your favourite just by looking at it. Pictures available on the website. So if you go to the Open Days page and click on college information, you can see some nice pictures and quotes about colleges. But none of them is best for maths because they're teaching the same maths, and none of them is the easiest to get into because we're going to take the best mathematicians no matter which college they apply to. Every year, about 25% of the people we take aren't made offers for the college they applied to. We redistribute people a little bit through the process, so that if one college happens to have loads of really good mathematicians apply, those people aren't disadvantaged. They'll get an offer at a different college, which maybe had fewer great mathematicians applying. So we're comparing notes. It's part of my job to make sure that we are consistent between different colleges. Okay, you also technically don't have to choose a college. You can make an open application. Open application means that your application is automatically assigned to a college, and then you're treated exactly as if you applied directly to that college. So the first thing that happens is you're assigned to a college, and then we treat you exactly as if you applied to that college. The people at the college won't even know that you did open application. So it's not an advantage, it's not a disadvantage, you're treated exactly the same. It's just there so that if you really don't care and you don't want to choose, you can just do an open application. Okay, colleges, great. More facts about interviews now. So we've chosen a college or not. We've done maths. Maybe we've been shortlisted and we've been invited to interview. These interviews are in December. For people in the UK, I'm thinking about our "Where are you from?" quiz again. For people in the UK, being invited to Oxford, and for state school students eligible for free school meals, or people in care, or with other compelling reasons, we'll pay your travel expenses. For people outside Europe, this might be an interview over the phone or over Microsoft Teams, sort of web chat thing. Either way, we're going to ask you maths questions. We're going to do maths problems to see what happens when we set a maths question for you to work on. And the nice thing about doing interview questions is that we can make them slightly harder than other questions because we know that we're going to be there to help you with them, to give you prompts on the question, and to help work you through times when you're stuck on the problem. So we can make them a little bit harder. If you come to Oxford, you'll get free accommodation and food while you're here for 2 or 3 days over the course of the interview period. And you get a chance to meet our lovely students. Anyone currently chatting to the students will attest that they are lovely. Right, okay. Interviews. I think I wanted to show you an interview question. I might come back to that and show you an interview question later on. Let's skip over that for now. More facts about interviews. So one of our processes to make sure people get seen by different colleges is that if you're interviewed in Oxford, we'll make sure you're seen by 2 different colleges while you're here. Your first college and also a second college that we assign to you. Interviews are academic in nature. We're going to ask you maths questions. Please ask us for help. Please talk us through what you're thinking during a maths question. And final point, we don't care what you're wearing. There's no dress code. You don't have to wear your school uniform. Wear whatever's comfortable. And it's December, so it's going to be cold. But we don't care what you're wearing. I'm currently wearing an Oxford Mathematics jumper. And this would be formal enough. I guess, yeah, okay, right. Formal enough? It doesn't have to be formal. Why? You can wear anything to interviews. They're great. Most of the interviewers are mathematicians who tend to be quite fashion unconscious as well. Oh gosh, I hope none of them are watching. So there's really no judgment about clothes. Right, I'm going to move on. Okay, I was going to show you an interview question. I might come back and show you an interview question later on because I want to rush through final bits of admin. These are our admissions criteria. We look at your past exams, which might be GCSEs or AS levels if you've already got some. We look at your predicted grades. We've got those things on your UCAS, the Euros and your teachers' rates. We've got your maths score, of course, and we've got your interview score, of course. We're looking for people who have the potential to succeed on our maths course. Okay, other things not listed on this slide. I mean, we don't care what you're wearing, and we also don't take into consideration extracurricular activities or things like that. So you might be really good at karate, but we don't take that into consideration. Unless it's making you great at maths, in which case, fantastic. Please show us how it's made you great at maths through your maths score and your performance at interview on some maths questions. Right, great, okay. Final tips on preparing. All of these have got the word maths in. Revise maths. Think about maths, and I mean that quite seriously, to think about links between things that you've seen in maths already and how they link together. Maybe something that you saw before, you've now seen enough things to get more context around it, and you can think about it more critically in a different light. Talk to people about maths if you can. I know that it's really difficult talking to people at the moment in the current situation. I'm talking to a webcam at home, but if you can have a conversation with anyone about maths that you're interested in, then I think that's good preparation for communicating about maths. Try some past papers like MAT or other test papers are available, and do some other maths problems. There's lots of other maths out there these days. If you're trying problems that you're stuck on, then you're probably doing good preparation for maths later on. Okay, I think finally I've got some other resources that you might like. In the UK, the AMSP has maths and further maths videos. They're also running some online events in the future. Ask your maths teacher to give you access to maths and further maths videos, or ask them to get in touch with the AMSP if they don't know about the AMSP. For complex numbers, you can go to enrich.maths.org/complexadventure. That's if you haven't seen complex numbers yet and you want to find out about complex numbers. That's a really fun resource for finding out a little bit about complex numbers on an adventure. Other resources I like, I'm going to rattle these off: Underground Maths, the STEP Support Programme, and Problem Solving Matters are all worth having a look at if you like. I've also been told that there are other maths live streams, that I'm not unique, that there are other people out there doing maths live streams, like Ask Maths Anything, or 3 Blue 1 Brown is doing some maths live streams as well. So other content out there too. Okay, fantastic. That was the quickest admissions talk I've ever done. So I've rattled through all the admissions details because I want to get onto the interactive part of this open day. So here's an interview question. I think this is going to work. I'm going to try and draw on this PowerPoint. Normally, of course, for an interview, we'd be in the same room. I'd be writing on paper. There would be a lot more space. My handwriting would be slightly better. So you come in. Normally, the interview starts. We check that we've got the right person in the right place. We don't do very much small talk. Mostly because I'm not very good at small talk. I find that the best way to settle down mathematicians is to just start doing the maths question. So I'm going to do that now. Here's my question. I used this last year. So the question is about a parabola, y equals x squared. And the question works like this. I'm going to put 3 points on the parabola. They're called A, B, and C. B is special because B is the origin. It's right at the bottom of the parabola. Okay, but A and C can move. A is somewhere on this side. C is somewhere on this side. And my question is about the triangle ABC. Let's try and draw the triangle ABC. Brilliant. Doesn't help that I've got the space of a napkin to move my mouse around it. Okay, so this question is about the triangle ABC. B is the origin, A and C are two other points on this parabola. I'd like the triangle ABC to be equilateral. Okay, this is a double test. Can I spell equilateral and can I write it neatly on the PowerPoint? I'd like the triangle ABC to be an equilateral triangle. Where should I put A and C to make this triangle equilateral? So this is sort of the opener or warm-up part of this question to get you comfortable with doing a little bit of geometry, talking to me about your ideas. Obviously, because I'm doing this talking to a webcam on my own, I have to keep talking. But normally in an interview, I'd shut up now and let you tell me what you think you'd try for this question. Let's simulate that. I'm going to go quiet. You can shout at the screen what you'd try with this interview question. That's a great idea. Let's try that now. Not sure I like this kids' TV approach. So people would try writing down coordinates for these points, maybe, writing down equations for these side lengths. Some people like marking these angles or using symmetry to say A and C are probably at the same height to make this triangle symmetric. If you put A and C at the same y coordinate, then the triangle's at least isosceles, which feels like a good start. And I like this. People talking about this out loud because they often say useful things that help us make progress with the question. So having this idea about putting A and C at the same height so that it's symmetric, we're not done, but we're making progress. And as an interviewer, I can pick up on that and say, great, we're making progress. Let's try and push to make this triangle actually equilateral. So some people like marking this angle as 60 degrees. Oh gosh, 60 degrees, and then telling me about telling me about tan and root 3. Some people like writing down these side lengths to make all of these lines equal. Either way, I think you end up with C at root 3, 3, and A at the kind of opposite point, A at minus root 3, 3. Okay, so by doing this question with you live, I get to see how do you approach a problem like this? Do you write down side lengths? Do you write down equations? Do you just get stuck in trying to solve your equations? Do you like trigonometry? And I get to see how you approach the problem and whether you can solve it, whether you can write down equations and then solve them. And I also get to, depending on how quickly we got through this bit, I've got a follow-up bit of the question where I make the question harder and I ask you a slightly different question. So depending on how this went, I might ask another question. I might say, how about instead I make triangle ABC. This is quite good, right? We've made an equilateral triangle. I might chat a little bit to try and see what other sorts of triangle can we make. If you had that idea about making isosceles triangles, I think it's clear-ish that we can make lots of other isosceles triangles. Maybe that's not super clear. And we might have a chat about that to see if we can explore that idea. Here's another idea. I might try and get you to do some algebra to find out if you can make triangle ABC similar to this triangle, 3, 4, 5. So here I'd also check live that you know what a similar triangle is, that you know what it means for triangles to be similar, ratios of their lengths or something, or having the same angles in the same order or something, to say, do you know what similar triangles are? And then I'd ask if you could work out how to make triangle ABC similar to this one. And I think there's lots of solutions by just like one possibility. Let's just try and find one solution of what to do with A, B and C. I mean, B's fixed to the origin. What to do with A and C to make this triangle similar to the 3, 4, 5 triangle. And again, there are ideas that students can have without solving the whole question. So there might be an idea like well, this triangle's got a right angle, so I should try and put a right angle in my ABC triangle. How am I going to do that? What does that mean for the coordinates of A and C? And people might try thinking about the ratios of side lengths and writing down some equations for the ratios of side lengths. The algebra for this part of the question is a little bit more messy. I'm going to leave it to you as an exercise to bash through. But I think the best way to do it is thinking about putting a right angle in and then thinking about ratios of side lengths. Okay, that was an interview question I did. I've rushed through it. Normally it would take me. Normally we'd go through this in sort of 15 or 20 minutes, talking about the question. We maybe get stuck on it. Maybe we try something and it doesn't work straight away, but we try a different approach. We try mixing things around to make progress with the question. We don't always get through all of the question, and that's fine. Even if we don't get through all of it, I still get to see how you deal with solving parts of a problem, or how you make a plan. And I like that it uses different bits and pieces of maths. I haven't written it on the slide, but you get to do quite a bit of algebra with this question, which is quite like. Also, it's about triangles, and triangles are nice.